Hello class, Professor Anderson here. Let's take a look at a vector problem. This is a two-dimensional vector problem. Let's say you are a punter playing football, okay? And here's the football field, and here are the yard marks along the football field, and you're going to punt the ball, and we want to know something about how far you end up going. All right, so let's say you start from the very middle of the football field. You're at the 50-yard line, and they tell us that a typical football field is 51 yards wide. We're doing SI units. Let's use meters, okay? So let's make that meters. Okay, you can convert to other units if you want. And let's say that we punt the football like that. Okay, and it goes a distance of 35 meters down the football field. We want to know how far is the resultant displacement and what angle did that football move at. Okay, so right off the bat, if that's 35, then this is, of course, half of 51, which is 25 and a half. So we'll put that number right there. And now what can we say? Well, this is a right triangle, of course. So for a right triangle, if we have A, B, and C, we know, of course, that A squared plus B squared equals C squared. And so C equals the square root A squared plus B squared. Okay, so you can run those numbers, plug in 25.5 for A, 35 for B, and see what you get. Now the second part of this says, what angle did that football move at? And they want to know this angle right here. Okay, so if that's the angle we're looking for, and now we know all the sides of the triangle, we can use anything we want, sine or cosine or tangent. Why don't we use tangent, okay? Tangent of theta is opposite, in that case it's B, over adjacent, which is A. So what's theta? It's the arctangent of that. Okay, once you know all the sides of the triangle, you could use anything you want, but tangent is a nice one because that's directly related to the numbers that they gave us. Okay, that should clear that one up. If you have any questions, come see me in office hours. Cheers. Hello class, Professor Anderson here. Let's take a look at a vector problem with two birds. And in this problem, bird number 1 flies 1.8 kilometers west and then 3.6 kilometers north. And bird number 2 flies 3.6 kilometers west and then 1.8 kilometers north. Okay, and we need to figure out what is the resultant angle between their two trajectories. Okay, so let's plot this out a little bit carefully. So here's our coordinate system. And we know that north is up, south is down, east is that way, west is that way. And so bird number 1 goes 1.8 kilometers west and then 3.6 kilometers north. So something like that. So their final displacement vector goes from the origin up to there. Looks like that. Now, the other bird goes 3.6 kilometers west and then 1.8 kilometers north. Okay, so their displacement looks something like that. And now, what are we looking for? We are looking for the angle between those two displacement vectors. We're looking for that theta right there. All right, so how do we do this? Well, why don't we draw out a couple triangles a little bit more carefully and see if we can calculate some angles. Okay, so this triangle right here, we have 1.8 and 3.6. How do I calculate this angle? We'll call that theta 1. Well, we just use tangent, right? Tangent of theta 1 equals 3.6 over 1.8. Okay, for the other triangle, which is a little bit shallower, we have theta 2, and now those numbers are reversed. This is 3.6, this is 1.8. So tangent of theta 2 is equal to 1.8 over 3.6. Okay, and so now you can take the arctangent of those. Theta 1 is the arctangent of 3.6 over 1.8, and if you look at that number, you should get 63.4 degrees. Arctangent of 1.8 over 3.6 is 26.6 degrees. And now we want the difference between those two. Theta 2, well, let's leave it like that. Theta 2 minus theta 1. And that's our theta 2, and that's theta 1. Let's switch them so we just get a positive number here. I think we want a positive number, so we'll do theta 1 minus theta 2. And if you take that difference, you should get 36.8 degrees. All right. Hopefully that one's clear. If it's not, come see me in office hours. Cheers.